Hello students, have you ever played with a magnet? Have you ever wondered why it attracts iron? Let us see more about magnets. There are two kinds of magnets, natural magnets and artificial magnets. Natural magnets exist in nature. They can be found in rocks and sandy deposits in various parts of the world. The magnetic property of natural magnets is permanent. That is, they never lose their magnetic property. The strongest natural magnet is lodestone. Lodestones were used to make compasses in the olden days. Artificial magnets are made by humans. Artificial magnets can be permanent like refrigerator magnets or neodymium magnets, or temporary like electromagnets. Students, we learnt about the electromagnetic effect earlier. Due to this effect, if an electric current is passed through a conducting wire coiled around a metal core, a magnetic field is produced around it. As soon as the electric current is stopped, the magnetic field also disappears. Such artificial temporary magnets are known as electromagnets. They are prepared by passing electricity through a conductor. In fact, students, have you seen electromagnets picking up scrap metal? The magnet starts attracting scrap even when it is at a certain distance from the scrap. You will also notice that the attracting effect of the electromagnet is not felt after a certain distance. Why is it so? This happens because there is an invisible area of influence around the magnet, where it shows its magnetic properties of attracting or repelling other magnets. This area is limited for every magnet and depends upon various factors. Beyond this area, the effect of the magnet cannot be felt. This area of influence around the magnet is called the magnetic field of that magnet. Let us understand this pattern with the example of a bar magnet. Can you quickly recall the basic property of magnets? Yes, you guessed it right. All magnets show polarity. Magnetic polarity means the alignment of the north and south poles of a freely suspended magnet in space. As you know, students, magnets have two poles. One pole of the magnet is north-seeking and the other pole is south-seeking. The north pole of a magnet seeks or aligns to the geographical north pole of the earth. Similarly, the south pole of a magnet seeks or aligns to the geographical south pole of the earth. In other words, magnets align themselves to north and south poles of earth. Now students, when you bring two magnets near each other, they exert some kind of force on each other. When unlike poles of two magnets are brought together, they attract each other, and like poles of two magnets repel each other. Now the question is how a magnet knows that there is another magnet out there and it has to attract or repel it. Well, let us think about it like this. Suppose your mother is cooking noodles for you. That moment you enter the house, you get the smell, and this is how you come to know that your mother is there in the house and she is cooking. So you see what noodles did? It just created a particular smell all around the house to make its presence felt. In a similar manner, a magnet creates some kind of magnetic effect around it. And when a second magnet comes in the range of this area of magnetic effect, it experiences the force of attraction or repulsion. Similarly, the second magnet will also generate a magnetic effect around itself, and the first magnet will experience the effects of this field. The area containing the magnetic effect of each of the magnets is the magnetic field of the respective magnet, and this is how one magnet knows about the presence of the other magnet. The only difference is that in the case of smell, there are molecules that mix with the air and spread around, while in the case of magnetic field, it is a force that gets created around the magnet. So students, in our video, we have learned that a magnetic field is an area where a magnet shows its magnetic effect. Magnetic field is specific area and fixed for every magnet where it can exert its force. It depends on many factors. We also saw magnets align themselves as per Earth's magnetic field. Magnetic field can be represented as magnetic field lines, which are closed curves around a magnet. We will study magnetic field lines and their properties in our next video.